Hello everybody, welcome to my channel. Today we're gonna discuss about the semi-partial correlation analysis using our software. In the previous tutorial we tried to discuss about the partial correlation analysis, which measures the strength of the relationship between two variables while controlling for the effect of one or more variables or one or more constant. The concepts between the semi-partial correlation analysis and the partial correlation analysis are more or less similar. With the semi-partial correlation analysis, the third variable holds constant for either the x or the y. But in the case of partial correlation analysis, the third variable holds constant for both x and y. So today we're gonna discuss the semi-partial correlation analysis using our software. Before skipping to analysis, there are three basic assumptions that should be to carry out the partial as well as the semi-partial correlation analysis. The first assumption is the variable should be continuous in a sense, maybe the score, maybe the scale, maybe weight, and etc. And the second assumption is there should be a linear association or a linear relationship between all the three variables. That means the x and the y variable as well as the constants. Constants may be one or more two variable. And the third assumption is there should not be outliers in our data. So for example, if there is outliers, you have to cap or you have to remove the observation that contains outliers. And coming to computing the analysis, let's import our data, and here's my data name is data. Here is data. Then I will import it, as you can see here. Yes, here is my data. Then again, in order to run both the semi-partial correlation as well as the partial correlation, you have to use a spcor package. So submit this one to our studio, and if you want to get the names of your data or the column heads, so you have to type name, you have to type the data in the name function, so it will list the column headings that found in your data. So I want to compare the plant height as well as the grain yield, while the BMY or the body mass yield considering as a constant. So BMY is holding constant for what? For only for GY. But if I want for the plant height, so you have to change this into here and this into here. So let's do a semi-partial correlation coefficient holding the biomass yield for the grain yield. So type this and submit to our studio. So as you can see here, the correlation here is the estimate is represents the percent correlation. So the correlation is 0.074, and again here also the p value, and it also gives the statistics and the number of sample that you are used. So by this way you can compute the partial correlation coefficient using our software for one constant. But for example, if you want to hold the constant for the pH, so simply type this, make copy, yes, make copy, then again here is make paste, then interchange GY and pH, yeah, over here, yes, then comma, then omit this comma. So in this case you are doing the semi-partial correlation analysis or semi-partial coefficient for the plant height while holding the biomass or BMY for the plant height. So you can submit in this way. So on the basis of this, the percent, the method is percent. You can change into candle or you can change into spearman. I'll show you later. Then as you can see here, the estimated means the coefficient, which is 0.04, it's weak, and the p-value is 0.49, which is greater than 0.05, so it's not statistically significant. And so by this way you can compute a partial correlation coefficient for the plant height holding the BMY as a constant. Furthermore, if you want to add more constants, for example, in this case we only used one variable. Again, here also one variable. But if I want to add more than one variable, you have to use this code. So over here you have to use the spcor.test. If you remember in the previous tutorial, to compute the partial correlation analysis, you have to use the pcor function, while here to conduct the semi partial correlation coefficient, you have to add scp. You have to use spcor.test, then immediately indicate your data name and attach the variable that you are want to compare or to do analysis. For example, here is a pH, and again you have to call your data, then attach using the dollar sign, and to represent the second variable, that means grain yield. Then here is the two variables that I want to hold a constant for the grain yield. And moreover, for example, there are three types of correlation, like the percent correlation, like null correlation, and as well as the Spearman correlation. So if you want to change, the default is as you can see, the default is the percent. But if you want to change into Spearman, or if you want to change into Kendall, you have to use a method is equals to Spearman, method is equals to Kendall, method is equals to Pearson. In fact, Pearson is a default. So by this way, you can submit for more than or for holding two or more constant. So here is a function spcor.test, then the planted, then grain yield. Then for the grain yield, we are holding tkw and FSPS variable holding constant. So in this way, we can compute semi-partial correlation coefficient when we want to add two or more constant variables. So type this and send it to our studio. Then you get the p-value. Sorry, the p-value here is 0.738, and the estimate is 0.024, and the method here is the Spearman. So the association between the grain yield as well as the plantage is weak according to semi-partial correlation coefficient. So this is all about today's tutorial. As usual, if you have any question regarding to my tutorial, you can address me through my email as well as YouTube comment box. Thank you for watching. Have a nice time.